All right, last lesson in Unit 7, which is Lesson 29. What we're going to do with this one is determine sample sizes that would be necessary to make an accurate estimate. The question will come up is, if you want to know a particular, whatever your question happens to be, how many people should you actually survey? Is it okay to survey 10 people? Is it okay you have to survey, 172 people? What is the number that you need to be able to come up with an accurate estimate? All right, so there's going to be two different ones that we're going to use. If we're talking about a mean question, this would be the formula that we use. And if it's a proportion question, then there is a different formula. Both of these formulas are on your formula sheet, by the way. So let's talk about mean first. So n is sample size, z is z-score, which we'll talk about those down here. This is standard deviation. So let's take these in here. So this is z-score. Obviously, that should be so this is standard deviation. This is the amount of error. All right, we're always going to take these problems and round them up. So if you get 27.8, you'd round that up to 28. If you got 27.2, you would still round that up to 28. All right, 0.2 of a person is going to count as a person, so we're already going to take that and round that up. Okay, so here's how you do z-scores. Let's say we talked about 95% being 2 standard deviations away. That would be the z-score I wanted. It's not exactly 2. So here's how it works. So that 95% is the middle 95%. Okay, so we're not looking at the extremes. If I want to come up with the z-score right there for 95%, I have to figure out what that is using inverse norm. So to do that, I need what's left over. So if the whole thing's 100% and that's 95, that'd leave 5% left over. So 2.5 on each side, percent. Okay, so if you remember from inverse norm, you're going from your line all the way over to the left. So that would be this 95 and this 2.5. So that'd be 97.5%. Remember, you type that in as a decimal. And we're going to use 0 and 1 as our mean and standard deviation. Okay, so inverse norms. Remember, that's second bars is what that's under. 0.975. I already have it typed in. Leave that on left. Hit paste. And then we get 1.96. Remember how we talked about that it was 2? Well, not quite 2. It's 1.96 is what it ends up being. So if I wanted, let's say 80%, it'd be the middle 80%. Means there is 10% left over on both sides, for a total of 100. Sorry, that's a percent sign. That says 10%. So I would do inverse norm. So from here over would be 90% that 80 and that 10. So the z-score that would go with that would be 1.28. So there are 3 that I would know. I would know that 90% is approximately 1.6. I would say either 1.64 or 1.65. Okay, because it's 1.6445. So 1.64, you're going to see probably in a lot of the homework, I'm going to put 1.65. Let's do 1.65 on that. That 95%, like we just came up with a few minutes ago, was 1.96. 99% is 2.58 for a z-score. It's the z-score. goes along with that. All right, let's go through this then. College president asks a staff teacher to estimate the average age of students at their college. How large a sample is necessary? So this is the question that you're looking for when you go to take the test of, do you use this formula? So the stats teacher would like to be 99% confident the estimate should be accurate within 1 year. So there's your error. From previous study, the standard deviation is known to be 3 years. Okay, so 99% z-score of 2.58. So our formula, n is equal to the z-score times the standard deviation divided by the error squared. So 2.58 times 3 divided by 1, which you don't need to type in necessarily, and take that and square it. So 59.9, so we will take that and round that up. So you would need to poll 60 people. All right, so for proportion, we're not going to have a standard deviation. We're going to have p hat, which then we'll have q hat as well. All right. If you are not given what happened in a previous study, then you're going to use 0.5 for p hat. All right, the researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. This is obviously an old question. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2%. Find the minimum sample size necessary. Okay, so our p hat is 40%, which means our q hat will be 60%. Remember, those two need to total up to 100%. And times our z-score, 95% is 1.96. And then within 0.2%. So on these, we're going to write that. So I should put that up here. The error written as a decimal for the percent. Okay, and take that square. All right, 0.4 times 0.6 times 1.96 divided by 0.02 squared. So 2,305. All right, here's one where they don't give p hat. Same researcher wishes to estimate the proportion of executives who own a cell phone. She wants to be 90% confident and be accurate within 5% of the true proportion. Okay, so since we don't know p hat, make that 0.5, which makes q hat 0.5. 90% 1.64. I'm sorry, 1.65. Accurate 5% squared. A lot of people forget that squared on that. 0.5 times 0.5 times 1.65 divided by 0.05 squared. Make sure you put parentheses around the 1.65 divided by 0.05 because you want to square both of those. So 273. Remember, always take that and round that up. All right, that's how you find sample size. That's lesson 29. Let me know if you have questions.